guys, if you're watching this video, this is the notes for finding the discriminant and using the quadratic formula to find the x-intercepts of a quadratic. So just to recap, just to review, first thing you should always do to try to find the x-intercepts, you should always check factoring first. It's the fastest, most efficient method. But the reason it doesn't always work is because when you're factoring, it only finds rational x-intercepts. So if the x-intercepts don't cross at a ratio or a whole number, then you can't factor, okay? Second method you should always check, and we'll talk about this more next week, but the second method you should always check is the square root method. It's the next fastest, most efficient, but that only works if it's in vertex form or if the b term is missing, the middle term. Then after that doesn't work, then you would check completing the square. But completing the square can get really messy if you end up with a fraction on the inside, which we've never done because I don't like y'all doing it that way. You don't need to know how to complete the square with fractions until pre-cal. So the method we would use when trying to complete a square, a perfect square trinomial, and we get a fraction on the inside, you would actually not want to complete the square at all. You would want to use this method, so quadratic formula. Before I can even teach you what the quadratic formula is and where it comes from and why it works, the first thing you have to know is how to find the discriminant of a quadratic. So let's go ahead and look at these guided notes. Hopefully you printed these off and put them in your notebook. The discriminant of a quadratic equation, that's a quadratic equation, is b squared minus 4ac, okay? The discriminant tells us the number and nature of the roots. So if you look at this chart that I made for you guys, if the discriminant is positive, so after I do b squared minus 4ac, I plug in the b value, the a value, and the c value. If I get a positive number for my answer, then that means the quadratic function has two real roots. So that means it's going to cross the x-axis right here 2 times, okay? If when I plug in my b, a, and c value into the discriminant, I get 0, then that means there's only one real root for the quadratic, which means it only crosses the x-axis 1 time, this time right here. Okay? And then when you plug in your values into the discriminant formula, the b, a, and c, if you get a negative number for your solution, then that means you have 2 imaginary roots. So remember, if they're imaginary, the parabola itself is not going to cross the x-axis. But remember, we talked about how its reflection or its shadow, the imaginary part, would touch 2 times. So if it had like a shadow or a reflection, then it would touch 2 times. You can see that right here on this pink part, okay? So first we're going to start off with just finding the discriminant of different quadratics so we know how many x-intercepts it has and what they look like. Are they real? Are they imaginary? That kind of thing. And then we'll move into how you actually find them using this thing called the quadratic formula, okay? So if you look at the bottom of your guided notes, there is an example for you guys to look at. I'm going to go ahead and start doing some off of the example worksheets that I put for you guys on Canvas underneath Wednesday. So it is front and back. We're going to do the examples off of the back. Okay. So I'm going to start with this second one right here. So this is technically number 6, this is number 7, and this is number 8. So we're going to start with number 6, all right? So in order for us to see what the a value, b value, and c value are, to put them into our discriminant, because this box says, I'm going to copy over the directions for y'all real quick. In this column, we're finding the discriminant. This one is number and nature of roots. And then this box right here is calculating the zeros. Okay? All right, so before we can even find the discriminant for this quadratic function, first we have to make sure that the equation is in standard form. So standard form looks like ax squared plus bx plus c, which means everything is on the same side. So hopefully everybody's okay with me moving the 3x and the 7 so that everything is on the same side, okay? So I'm going to subtract 3x over. There aren't any other x's, so it's going to go in the middle. And then I'm also going to subtract 7, because you do the opposite to move it. So this is now just going to be y equals 5x squared minus 3x. Remember, you can't combine those because they're not like terms. But then negative 4 minus 7 is going to give us negative 11. Okay? So this is my quadratic function in standard form. Now our formula for finding the discriminant, I'll put it up here, is b squared minus 4ac. Okay? So when I do b squared minus 4ac, my b value is the negative 3, my a value is 5, and my c value is negative 11. So to find the discriminant, we're going to do negative 3 squared minus 4, my a value is 5, and my c is negative 11. So b squared minus 4ac. Negative 3 squared is going to give me a positive 9. Negative 4 times 5 is going to give me negative 20 times negative 11. I did not bring a calculator, which is great. I'm going to have to go grab one of those real quick. 20 times 11 is going to give you positive 220. So this is going to be positive 229. Okay, so when we did our discriminant, we got a positive number, which means this quadratic is going to touch the x-axis twice. So number and nature of roots, what this means, if it's positive, is that we have 2 real roots on our graph. Okay? So that's all you're doing when you're finding the discriminant. You're using this formula, b squared minus 4ac, to figure out how many roots you have. I will attach a video to Canvas that shows you where this formula comes from if you're interested to see. But I know some of you probably are not because you're not nerdy like I am. So we're going to keep doing a couple more discriminant examples, okay? All right, for number 7, this one is already in standard form, which is super nice. So if you look at this one, the a value in front of the x squared looks like it's an understood 1. The b value is negative 3, and the c is positive 4. So when I do b squared, that's going to be negative 3 squared minus 4. The a value is 1, so times 1 times 4. Negative 3 squared gives me 9. 9 minus 4 times 1 is negative 4. And then we still have this 4, right? So negative 4 times 1 is negative 4. Times 4 is going to be negative 16. So this is 9 minus 16, which equals negative 7. Okay? So when I do my discriminant for number 7, we get a negative number. The discriminant is negative 7. So when you get a negative discriminant, remember that means your quadratic does not touch the x-axis at all. So when it's negative, if you look at the table that I made for you guys in those guided notes, we get 2 imaginary roots on our graph. Okay? All right, so we'll do one more just so we can get in the practice. So I'm going to move this 3 over to the other side with all the other terms because it has to be in standard form. So we're going to do the opposite of a positive 3 and subtract it. So this is going to be negative 3x squared plus 17x minus 5. And technically it would equal 0 because we're solving. Anytime you're solving a quadratic, you're finding the x-intercepts, which means the y value is 0. You set it equal to 0 to find them, okay? So from here, my a value is negative 3, my b is 17, and my c is negative 5. So now I'm going to substitute that into the discriminant formula, and you do just have to memorize this. You have to know it. So b squared minus 4ac. My b value is 17, so this is going to be 17 squared minus 4. My a is negative 3. and my c is -5. Okay, so 17 squared is 289, I think, yeah. And then -4 times -3 is going to give me +12 times -5. Remember, you have to do multiplication first. This is PEMDAS. So 12 times -5 is going to be -60. So we have 289 minus 60, which also gives us 229, which is weird. That's the same thing we got up there. Very interesting. Okay, so again, we got a positive discriminant. You know by now that if it's a positive discriminant, that means that we have 2 real roots on our graph. Sound good? All right, so this is how you would find the discriminant of a quadratic equation.